Here we construct the graph of the sine function, something everybody did correctly in the final without having seen it before, according to simple instructions. Okay, so this construction simply it's actually a very simple construction using a compass and straight edge. So we start, pick a point for the center of a circle, and construct a circle of some radius around that point. We want a fairly big circle because we want a fairly accurate version of our sine function. Now, we take the angle between the positive x-axis and the positive y-axis. We construct the circle on a set of xy coordinates, as you see here. We take this, and it's a 90-degree angle. Okay, we take this angle and we construct its bisector. So if we construct it carefully, well, how do we construct the bisector? The construction of the bisector is in white. So we simply swing this arc. Now what's this arc? This arc is about this point. And then we swing an arc of equal radius about this point. So we have this arc swinging around here, this arc swinging around here. Now I happened to use a radius that was equal to the radius of the circle. So these arcs actually meet at the origin, or very close to the origin. With chalk and so forth, I can't be really completely accurate. So this one looks like it really is heading for the origin. This one's maybe a little bit to the right of the origin. We still get the idea. And had I used a shorter radius, would add a set of shorter arcs. And if I had a set of shorter arcs, the point of intersection between the two arcs here and the point where the two arcs intersect here, and those points might have been like here and here rather than here and here, those 2 points would have aligned, if I did it correctly, with the center of the circle. And a line through the center would have gone through both intersection points of the two arcs, and the angle I got, as you should be easily able to prove, is going to be the bisector of this 90-degree angle. Now you might ask why I didn't take a protractor and measure it, because we're not doing anything with numbers, and because a protractor is limited in its accuracy, whereas we're talking about wanting to construct with compass and straight edge, which can theoretically be done with complete accuracy. So here we have the bisector, and anyhow, this is bisector of the first angle, the angle between the positive x and positive y axis. Of course, we know this angle is 90 degrees, we know this angle is 45 degrees, but that doesn't make any difference. We're not going to use that fact at all right now. Later on, we'll draw some conclusions from that fact. Okay, then I want to bisect this angle. Okay, the angle between the positive x-axis and the bisector I just constructed. And I do that in a slightly different way because, as you can see, the figure already gets pretty well cluttered. And I use purple. And I didn't include all the arcs and everything that I used to do that construction. I simply, in this case, rather than swinging the arcs, well, rather than drawing the arcs like I had here, I simply said, well, okay, we can do the equivalent thing if we take the perpendicular bisector of the line that joins this point to this point, the point where this line intersects the circle, the point where the positive x-axis intercepts the circle. And I drew that perpendicular bisector without the attendant arcs. The arcs you would draw to do the perpendicular bisector, and this is something I assume you know how to do because we did it, and everybody seemed to pick that up very quickly, are the same as the arcs you would use to bisect the angle, because finding the perpendicular bisector of this segment, you could prove geometrically by similar triangles and so forth, is going to give you equal angles here and here, so that this angle does bisect this angle. Then I didn't draw any of the intersection lines, but in green here I drew another bisector. That's of the angle from here to here, from the original bisector of the 90-degree angle up to the y-axis. This gives me 1, 2, 3, 4, 5 points on the circle, and they're equally spaced around the circle. In other words, the arc from here to here is the same as the arc from here to here, same as the arc from here to here, same as the arc from here to here. From each of these points, now there are 5 points, but I numbered them 0 through 4 because I want to start at 0 with the first angle. And I want my points to be numbered 0, 1, 2, 3, 4 for reasons you'll see in a minute. Okay, so starting with point 1, well, let's go to point 2. Okay, for point 2, I constructed a line perpendicular to the y-axis from point 2. And how did I construct that line? Well, that construction is in yellow. First thing I did was I swung an arc here that intersected the y-axis in 2 points. Then from here, I swung an arc here and continued that arc, although I didn't keep the chalk down, over here. So we've got an arc here and an arc here, same radius. And then from this point, again, 2 arcs of the same radius. Points where those arcs meet will be in line with this point here and with the and will make a right angle with the y-axis. Okay, I was going to say with the bisector of this segment, but that, what we've constructed is the perpendicular bisector of this segment, but I didn't need to say that. Okay, so it should be clear. I've got a right angle here, so what I've actually done is I've projected this point over to the y-axis at a right angle. Okay, now I didn't draw construction lines, and I didn't actually do the construction. I just sketched the lines in. But from point 1, I did a similar thing. I projected this point to the y-axis. From point 3, I projected a point to the y-axis. Point 4 is on the y-axis. At point 0, I didn't draw a projection line, but it obviously projects to the y-axis at the origin. Now, I've got a set of x and y axes over here. Not the same as a set of x and y axes I had over here, but this x-axis is actually along the same line as this x-axis. And then I've got a y-axis that I just constructed. I didn't actually construct it, I drew it, but I could have constructed it, okay? Could have constructed every bit of this by compass and straight edge. Then I simply extended this projection line over to this point, this projection line over to here, this projection line to here, and this a line parallel to all these projection lines from here to here. And I didn't draw that in because things are getting a little bit cluttered, but we understand that this point is, from this point to here, is a perpendicular projection onto the y-axis. Okay, now I have 1, 2, 3, 4 y values, 5 y values if I include 0 for this point. So I've got a y value for every numbered point. This is going to allow me to construct a graph of what we will be calling the sine function. Now I'm going to, and of course I'm not constructing this, I'm not going to get it completely accurate. Okay. Now, in preparation for the fact that I'm going to continue this construction all the way around the circle through all 4 quadrants, I break the x-axis into 4 equal intervals. Then within each of those intervals, I have 1, 2, 3, 4 angles. I've broken the first quadrant into 4 angles, and I'm going to do the same with the subsequent quadrants. So I'm going to go ahead and subdivide this quarter of my interval from here to here. Okay. Then I want to locate points on my graph. And I'm looking for different color chalk. Okay, so point 0 corresponds to an angle that we're going to call 0. Or we don't even have to talk about angle, but I'm going to call this angle 0. I'm going to call this angle from here to here 1. The angle from here to here is going to be 2. The angle from here to here is going to be 3. From here to here, the angle is going to be 4. And then we're going to extend that around the circle in a minute. Okay, so for this point, my y-coordinate is 0, and my angle is numbered 0, so I'm going to put this point here, the point corresponding to this point at 0, 0. Then the point corresponding to 1, to angle 1, is going to have the y-coordinate that I've got here. So here's going to be my angle 1. So here are my angles, 1, 2, 3, 4, and of course 0 is here. So above the point corresponding to the number of this angle, I sketch the corresponding point on the graph. And then for point 2, my y-coordinate is here, my x-coordinate will be here. Let's see if I can do that. Okay, then point 3, so I've got to come straight up, and I'm not going to get these completely accurate. And point 4, I've got to go a little further to the right, and I've got a point here. Okay, so now I've got 4 points, and I can connect those points with a nice smooth curve. Now I want to consider what happens if I continue going around the circle, and this video is already plenty long, so we're going to continue in another video to extend this graph.